So today we want to discuss Pythagoras Theorem, a fundamental theorem to geometry and mathematics. Now, there's something extremely important that I need to point out before I begin. The Pythagoras Theorem applies only to right-angled triangles. What is a right-angled triangle? It's a triangle that has a right angle. And what's a right angle? A right angle is an angle measuring 90 degrees. And 90 degrees angle would usually represent it, denote it with a little box in the corner there, just to indicate that that angle is a 90-degree angle, or what we call a right angle. Now, the theorem states that in a right angle triangle, the square of the hypotenuse side, and let me just highlight what the hypotenuse side is. The hypotenuse side is a side that is opposite to the right angle. So in this case here, the hypotenuse side, we label it as C. Generally, we label it as C or H, or you label it whatever letter you want to label it. Just for the sake of the formula here, we label it C, but it's up to you. You can label it using any letter in the English alphabet, the Roman alphabet, the Greek alphabet, or any other alphabet. Good? But we just choose to label it C. So the hypotenuse will label C, and you realize C, this hypotenuse here, is a side opposite to the right angle, to the 90-degree angle. So in a right angle triangle, the square of the hypotenuse side, so the square of C is up to the top right hand corner there, representing the Pythagorean Theorem. The square of the hypotenuse side, indicated by C square, is equal to the sum of squares of the other two sides. And this is how we represent the theorem. So, this side, the hypotenuse side, and by the way, it's the longest side. Always the longest side of the right angle triangle. So the longest side square, or the hypotenuse side square, is equal to the sum of the square of the other two sides. The other two shorter sides. So, C square is equal to A square plus B square. Now, addition is commutative, so you could write it as C square equal to B square plus A square. It doesn't matter if you put the A square first or the B square first. It doesn't really matter. A square plus B square is same as B square plus A square. Good? When you're adding two values, the order does not matter. Alright, and by the way, we label these two sides. You can use whatever letter you want to label your sides. You could use X and Y and Z, L, M, N, J, K, L, any letter you want to use to represent them. But for this instance, we're just using these letters just to give you the essence of what Pythagoras Theorem says. This side square, that's the hypotenuse side square, and the hypotenuse side is the side opposite to the right angles. So the hypotenuse side square, C square, is equal to A square plus B square. Alright? And by the way, so let's say, for example, I have a right angle triangle. Let's say turn like that. This is the right angle. Which side is the opposite? Which side is opposite to the right angle? This side. So this would be your hypotenuse. Let me call it V. And let me call these T, and let me call this R. I just want to write the right angle triangle, write the Pythagorean theorem using different letters, because sometimes students get caught up into the letters, but the letters not really important, have no importance any at all. What's important is the essence of what the formula says. So the longest side square, or the hypotenuse side square, which would be V, so V square, which is the hypotenuse side square, is equal to the sum of squares of the other two sides. So it will be equal to T square plus R square. Or you could write R square plus T square on the right hand side. It doesn't matter. And note very importantly, the square, all the terms have a square. All the sides we label, all of them have a square. And notice the hypotenuse is on a side by itself, on a side of the equation by itself, and the other two sides are together on the other side of the equation by themselves. Right? So let's get some practice working some problems. Okay, let's see if we can find the length of an unknown side here. Here we have a problem. I have a triangle here to the right hand side of the screen. It's a PQR triangle, and we are told that the length of PR is 8 centimeters. The length of QR is 6 centimeters. And we are being asked to find the length of PQ. And of course, so here we have a triangle, and we are given the length of two of the sides. I want to find the length of the hypotenuse side, which is PQ, the third side here. So applying Pythagoras Theorem, no, it's up to you what you want to call PQ. You can call PQ PQ. You can call it X, you can call it Y, you can call PQ whatever you want to call PQ. You can call it little r, because that's how we would label it generally. So, what is the length of PQ? Let us choose to call PQ. Let us choose to call PQ X. Let's call PQ X. I'm going to call PQ. I'm calling PQ X. Which means that applying Pythagoras theorem to this triangle now, the hypotenuse square, which is what we're calling X here, hypotenuse square, is equal to the sum of squares of the other two sides. This side and this side. So 6 square plus 8 square. Or you could have put 8 square plus 6 square. It doesn't matter which one you put first. So x square is equal to, what is 6 square? 36. And what is 8 square? 64. So x square is equal to 100. 36 plus 64. And to find the value of x, we take the square root of both sides. So the square root of x squared is x, and the square root of 100 is 10. So the value of x is 10. Hence, the length of PQ is 10 centimeters. So we can say, therefore, PQ equal to 10 centimeters. Let's look at another problem.